Physical quantities can be classified into two types: scalar physical quantities, or called scalars, and vector physical quantities, or called vectors. A scalar physical quantity is the quantity which can be described by a magnitude only. Of course, this magnitude may have a single number with a suitable unit. Examples on scalar quantities: distance, average speed, mass, time, energy, temperature, etc. An example on scalar physical quantity is the mass. You see here, this person is telling us happily his mass, 160 kilogram. Of course, 160 is the number that represents the magnitude. However, kilogram is the unit of mass in the international system. So there is no direction at all in this example. Another example on scalar quantity is this. This person has a fever. So he has been asked, what is your temperature? He says 40 degrees Celsius. Now here, 40 is the magnitude of his temperature, while degree Celsius is the international unit of temperature, which is also called centigrade. The other kind of physical quantity is a vector quantity. So a vector quantity is defined as a physical quantity which has both magnitude and direction. Examples on vector physical quantity: displacement, velocity, acceleration, force, momentum, etc., etc. An example on a vector physical quantity is the velocity. In this example, the car is moving fast. The speedometer of the car reads 160 kilometers per hour, while this is the magnitude actually of the velocity, while the direction is due west. Well, force is another example on a vector physical quantity. Here, this man is lifting weight. The magnitude of the weight lifting up is 1000 newtons, while the direction is upward. When you have a letter like A and it has at its top an arrow, this gives a vector notation. This indicates that such vector must have both magnitude and direction. Now, a vector is actually represented by an arrow which connects an initial point with a terminal point. Now, if you want to draw a vector, you need to carry the initial point to the final point. That's why the Latin word of a vector means carrier. Saying that a vector must have magnitude and direction, how can we write the magnitude of a vector? The magnitude of a vector can be written as A without an arrow at the top of it, or the same vector notation but in between two parallel lines. However, the direction of a vector must be specified with respect to an axis of reference, and usually this axis of reference is the positive x-axis. Now, to conclude, the magnitude of a vector must always have a positive value, while it is represented by the length of the vector. This is an example on a vector physical quantity and its representation. So the displacement, which is defined as the change in the position of a point, is given here as A. If we draw the vector A from an initial point P1 to a final point P2, this means that we displaced an object from the initial point P1 to the final point P2. In this case, the length of this vector represents the magnitude. However, the head of this vector refers to its direction. To test our understanding of the concept of the vector, let's ask the question: can the magnitude of a vector quantity have a negative value? The answer: no, it can't be a negative, because the magnitude of a vector quantity is always positive.